Hi, good morning, I am John. Today we are going to discuss about forward pass and backward pass. So, first, the question is, what is forward pass and backward pass? Forward pass and backward pass are among the two ways to analyze project activity network. Let's start with forward pass. So what is forward pass? Basically, the term of forward pass came from American football game. Forward pass in football is the quickest way for the quarterback to advance the ball down the field. In project management, the forward pass is the quickest way for the project manager to advance the project along its planned schedule. The goal is the determination of critical paths. It's used to compute earliest start and finish dates for each activity. It is an additive move through the network from start to finish. There are some rules that need to remember by heart. First, sum of early start and duration is early finish. Next, early finish of predecessor is equal to early start of successor. And third, largest preceding early finish at merge point becomes early finish for successor. Let's have an example.
Put 0 in for its earliest task time period. So its early start is going to be 0. We add to that 4 for the duration, and we get the early finish. You see the formula up at the top there, early start plus duration equals early finish. What we're going to do then for task B and C is we're going to carry the value of 4 into those other tasks. We're going to take the early finish from A and make that the early start for B and for C. So in B here we have 4 as our early start plus the duration of 8. That gives us 12. In C we have the 4 from A, we add to that 3, and we get 7. In D we take the 12 from the early finish of B, we take that over to the early start of D, and we add 2 to that, and we get 14. In E we take the 7 from the early finish of C, and we move it into the early start of E, add 3 to it, and we get 10. But now when we get to F, since this is a merge activity, we have two values from which we can choose. We can either choose the 14 from D or the 10 from E. Well, we're really dependent on D getting done here, so we're going to take the larger value. Okay, so in the forward pass, a quick and easy thing to remember is that we always take the larger number on the forward pass. So 14 plus 10 is 24. So now we've completed the early pass, or the forward pass, through our network, and we've determined the early start and early finish for all of our tasks.
Let's talk about backward pass. Backward pass is used to determine activity float as well as critical path. It is a subtractive move through the network from finish to start. Backward pass is used to calculate latest start and finish dates activity. There are some rules for backward pass. First, the difference between late finish and duration is late start. Next, late start of successor is the late finish of predecessor. Third, the smallest succeeding late start at a burst point becomes the late finish for predecessor. Let's have an example.
Let's do the backward pass. The calculation here is that the late finish minus the duration equals the late start. We're going to start out with F, and we're going to put 24 into the late finish for that last task in our network. Subtract 10 from that, get 14. We're going to then carry 14 down to E, minus 3, and we get 11. We carry that 11 over to C, minus 3, and we get 8. Let's look at the top row here. If we take that 14 and put it into the late finish for D, minus 2 from that, and we get 12. Take that 12 and put it over into B, minus 8 from that, and we get 4. Once again, we have a situation. A is a burst activity, so when we come back into A for the backward pass, we find that we have the values 4 and 8 that we can use. What we're going to do on the backward pass is we're going to always take the smaller number on the backward pass. So between 8 and 4, the smaller number is 4. 4 subtract 4 is 0. So now we've completed both the forward and backward pass throughout our entire network.
Let's continue with activity float, which also known as slack. Float means the maximum amount of time that you can delay an activity and still finish your project in the shortest time possible. It is determined as a result of performing the forward and backward passes through the network. Float can be calculated by subtracting early start from late start, or subtracting early finish from late finish.
Now let's look at the calculation for slack. What we're going to do is simply subtract the early start from the late start. And we can do that with A, we have a slack of 0. With B, we have a slack of 0. With D, 0. And F, 0 as well. That's what we're expecting to see, because by definition those items that are on the critical path have a slack or float of 0. If you look at C, however, 8 minus 4 is 4, and on E, 11 minus 4 is 7. So in this case, C could be delayed by 4 days without impacting the rest of the project. Or E could be delayed by 4 days without impacting the rest of the project. However, we cannot delay the C by 4 days and E by 4 days together, because that would be a total of 8 days and then would in fact impact the project.